Hello, this class for grade 12C. Okay, this is a new lesson. We are waiting for long time. Gonna go for the new lesson. Waiting for your guy. Okay, anyway, this is a new lesson matrices. Okay, the represent information as a matrix. Because when we do matrix, sometimes like for example, we have in the stock many things, right? We use matrix to count our warehouse or stock. This is is very helpful. Okay, so you see this example how we're gonna use the matrix, how we're gonna use the idea of the matrix in mathematics. Okay, this one can use for your daily life also. Okay, first one, represent information as a matrix. The example here below here, the following table shows the stock of pens at two stationery shops. Okay, we have two shops, but they have three kind of pens. On the top here, this is the name of pen. Okay, Pirate, Pentel or Pentel, and a red leaf. Okay, and then they have two shop one like a Pirate. They have 94 pieces, and this for the second type of pen have 104, and the last one red leaf have 70 pieces. And shop two, this amount or the table, the number here it show the amount of the number of the pens which they have in the stock. Okay, so normally we write in this table like this, right? But when we talk about matrix, we can write it down as a say this. We can write down, for example, here. We gonna use like a kind of bracket like this, the big bracket. Okay, and then we write down 94. Okay, and 104. This represent for each kind of pen in the shop one, and the second shop is the first one Parrot have 65, and second type of pen is 83, and the last one leaf is a 54. So we're gonna represent in this kind of bracket some and like this. Some handout they like this one. It's okay. So it's okay. Can like a little bit curve or like an angle bracket like this. So when we see this, we know this one. When we read this one, this rectangular array of the number in rows. Row mean this way. We count this one as a row. Okay. And down here count as a column. Okay. So when we write in this pattern row and column here, so this we call a matrix or matrices. Okay. So in this case, we can say this is a row one or the first row one, and this one row two. Okay. And this one will represent as a column. Column one, and this column two, and this gonna be column three. Okay. Ooh, gone. Okay, that's okay. So now this one gonna be column three. Okay. So when we read down like this called column, and when we go read for to horizontal, this represent row, and this one vertical represent column. Column one, column two, column three, row one, row two. Okay. So this is the way how to read for the matrix. This represent for the data we have. Okay. From this table. Then when we this one in this case we can see how many row we have. We have what first row, second row. So we will write it down here. We will normally we're gonna write down here. First one we have two rows, 1 and 2, and then time. Okay, so use the sign and then time, the sign multiplication, and the column we read 1, 2, 3. So we have 3 columns. So you write it at 3 here. So when we read this one, we're gonna read This is order or dimension. So we read as a 2 by 3. 2 represent row. 2 represent row. And 3 represent column. So we will write the row first and then column. So 2 row, 3 column, 1, 2, and 3. Okay. So we have 2 row and 3 column. Now we can try more example. Like for example, if I write it down as a, if I like this one, right? I like the matrix like this one. Maybe -4, 5, and bring down here. Between each number, the represent the data, no common sign, between. Okay, we leave it blank like that, but we have some space. So like a -5, maybe 2, 1, or maybe 1, 6, maybe 0, -8, like this. So in this case, we can read how many row we have. First row, second row, third row, and fourth row. So we have four rows. The row we have 4 rows. And how many column? 1 and 2. So we have 2 column. So when we read the order, gonna be 4 by 2. When we read 4 by 2. Or another example, take a look. If I like in this way, maybe 2, 3, 6, 7, or maybe say 1 minus 4 minus 9, or even 25, something like this. Okay, if we like in this one, you can how we gonna read the have like a the order, right? How many order they have? So you read first row, second row. So we have 2 row. Time how many column? 1, 2, 3, and 4. So we time 4. So this the dimension or the order is what? 2 by 4. 2 row, 4 columns. 2 rows, 4 columns. Okay. So again, we always represent the first one as a row first, and the last one, the second one, represent as a column. Okay. Now inside here, each number we call this one element, or sometimes we call entry. Okay. So like this, the first row, how many elements we have? We have 4 elements or 4 entries. And column, we also have the how many elements. So in the matrix, the whole thing, total, we call the number, each number as an element, okay? So you can count total how many we have. We have 8 elements in this matrix. Okay, at the same time, sometimes we can assign, say, oh, this, for example, like this example, right? Come back to the first one. We can assign this like a matrix A, you can name it like that, and A equal to like this to this matrix pattern. So A represent what? The whole stock, how many pens and how many shops they have. That's a represent matrix A. So you can call as a short name as A or whatever alphabet you want, or like the full name of the stationery shop or something equal to this one. Okay, so now from this more definition, see more definition. If I like it this way, for example, I separate them, okay, so won't mix up. So see more example, if I say, maybe I give the matrix in this pattern. For example, I like this, right? maybe 3, 6 like this, okay, or even or I can write down like this one more, like maybe -2, 6, 0 like this, okay. So in this one, how we read, how many row we have? 1, 2, we have 2 row, 1 column, okay. So and also this one is what? 1, 2, 3, have 3 row, 1 column. So in this case, if we have only this one, like in this one, only 1 column, we call this a column matrix. We call this one a column matrix. Okay, we call this pattern a column matrix because there only 1 column. So if I write it down as this one, say maybe if I write in this shape, maybe 6, 3, or maybe I can write down, say 7, no comma, okay, no comma, sorry. Shouldn't have comma there, this one, or maybe I can say 3, maybe 37, -9, or maybe 5 like this, or 6, okay. So I like this one we call row because only 1 row, so we call a row matrix. A row matrix, okay. It's only 1 row, and this one like up here is a 1 column only, so we call a column matrix. So in this case, we call a row matrix. How many row we have? Only 1. How many column we have? 2. Same thing, this one, how many row we have? 1. How many column we have? You count 1, 2, 3, 4, so times 4. So it comes with this shape we call row, because have 1 row and 1 column, we call a column matrix. Okay, this most of definition as just say introduction of the matrix. How we, the pattern or the shape, the form, we should write it down, okay? And you can represent a data. Each data inside the matrix we call elements or entries. And when we read the order, we will read the row first. This one called row, come to this side, read row. If you read down, mean columns. Okay, so like this one row, read row first and then follow with column by using the multiplication sign. This one is the read the order of the matrix. So become 2 by 4. And this one become 2 by 3, something like this. Okay, so next maybe we go more examples, 1 or 2 example more, and then gonna be that's all for this class, for today, I mean. So we go next one, example. The example said the number of boys and girls in the 4 levels at a certain secondary school are given in the table below. This is a table. Okay, like this school have how many? Section 1 have how many boys? 212. Section 2 have 204. Section 3 and so on. Okay, and how many girls? Section 1 is on the table. Everyone know how to read, right? But then if this one see want to represent in the matrix form, represent the above information as a matrix, state the order of your matrix. Or this one should like something, say if you want to represent, just say, can I write down, say represent. This question want us to do, say represents the above information as a matrix. State the order of your matrix also, okay? So how to do this is easy, right? Like before the previous example we just finished. You just lie in the solution, you lie how to lie in the matrix as a matrix pattern. You can do by, you can lie like this, right? Any like a big bracket here, and then you just lie 2, 1, 2, and 2. Just lie the low. You want to lie low first or column first? That's a matter. Depend what you feel is you like it to lie, okay? But make sure they complete every elements in this matrix. So this one light up become 193, 202, 194, and this 203, and then close. Okay, this one represent the matrix pattern, and then they want to find state the orders. State the order, then again you just read how many row and column. So we read from here, right? It's the first. This one is the first row. This one's a second row. When you read down, become column, right? Actually, they just use the idea when you learn function and learn kind of function. When you plot graph like on the coordinate plane, this one y, right? And this one x. The same thing, right? If you read from like this one, you read from according x-axis. This is a horizontal. This is a horizontal, right? Horizontal. That's equal like a low. And then we read from this one is a vertical, right? This become column, that's all. If you read according the y-axis, become vertical. Vertical mean that you read according the y-axis. So in this one, you read what? How many row we have? 2 row, 1 and 2. So you like the answer for order. The answer for order, okay? You just like that become 2 times. How many column? 1, 2, 3, 4. So the order answer is 2 times 4. I mean 2 by 4. You can read 2 by 4. And the represent the information of as a matrix here. That means this part. Okay, so that's all for this one. Okay, beginning not too hard. You try to understand the pattern first and definition, how to use, what the meaning, and later on gonna be a little bit complicated because we're gonna start to plus to multiplication to do something else. Is a little bit more complicated, but not hard. Okay, just only remember the definition and how to use, how to write it down. That's it. For next one, the example. Next example, a survey was done to find out which color is in the most popular among a group of 150 people. Okay, total we have how many? 100 in the group have 150, and 53 of them prefer blue. Okay, this one prefer the blue color. Okay, 53 prefer the blue color, and 48 what they like, 48% like the black color. And next one, 35 white, right? 35 need white, and the rest are red, and the rest are red. Represent this information as a column matrix. Now they want you represent as a column matrix. Represent this one as a column matrix and state the order, and then find the order also. Okay, so from this information, we can see how many people they have when they survey 150 total, right? But then this 53 light blue, 48 black, 35 white. So the red color we don't know yet. So how we get for the first, how many people prefer the red color? Okay, so we just get we're gonna have number, right? The solution we can do by number of people who prefer red, right? become equal to what? Get the total, right? 150 minus 53 minus 35. Total minus all the we know amount people who prefer which color. And then what else? We have 53 minus 48, 48 here. Okay, just 150 minus 53 minus 48 minus 35 and minus 53. So how many? And then you find out, use a calculator. We left 14, correct? So because when you sum it up, have to be equal to 150. 150. Okay, once you know the person who prefer red, now we can write the column now, right? So how to write in the column matrix? How to write the column? Column should be like this, correct? So we have this one, column matrix. We can write it that way. So we start from what? 53, right? 53 who prefer blue and 48. Maybe I use 53 prefer blue. So I like 53 here. And 48. This one 48. And the white one, maybe I can use another color, maybe like a yellow, maybe 35. That's a white color. But the red one, the person prefer red, gonna be 14. Okay, so when you write the matrix, should like cover or okay, cover or up here. And then this one can I erase a little bit here. Okay. So now this is a column matrix. So this represent the column matrix. Represent the column matrix. And then you can see orders. How many orders have? Count 1, 2, 3, 4. So you have 4 times 1 column. See, when column matrix, that means have only 1 column, correct? Row matrix, that means have 1 row matrix. Like example, previous example I just explained. So that's all for this example that you need to do. Okay, so order equal to 4 times 1. Okay, column matrix mean this shape, you lay down. Okay, so we go next example, right? Next example. Okay, no more example, but then gonna explain about more definition, equality of matrices. How we gonna cause the equal? Okay, for example, if I give you information, I give you any information, maybe like a matrix here, right? The shape. Maybe I lay down, say, I say matrix A, say equal to this one. Maybe say A, B, right? Like a last example, we have what? The one talk about the stationery shop, right? If I use the information, okay, it's gonna be 18 here and 192 here. Okay, so I use the previous example, the stationery shop, okay? So this one maybe if I like as a C, and this one 202, and this one say D, and this one says 203. If I like unknown like this one, right? So from the previous example about the stationery store, right? We have this one 212. If you go back to previous example, okay, the first example, we have the pen in the stock according this one for each kind, and then 192, and this one is a 193. 202, 194, 203. So if this one, how we call equality of matrix, must have exactly equal row and column. We just can say they're equal. Okay, like this one, for example, we have this how many row? 2 rows, right? So represent this one. 2 row, how many column? 1, 2, 3, 4. Same, correct? And this one also, how many row? 2 rows and 1, 2, 3, 4 columns. Same, right? They have the same order. Then if in this case, it's really obvious, we can say, from this one, we can say A, this A equal to 2, 1, 2. That means if you go back to see the first example. First example talk about the school, right? This one, I think this information this information is the talk about the secondary school, the example one. Okay, and the second page you go back to see. Then we can say A equal to 212. That is a section, the secondary school section 1 for the boy have what 212. Okay, and then from this one B gonna equal to this one 204. Okay, at the same time C, the same position here, we can say this one's a second row first column, second row first column. So C equal to 193. And D, you can see D second row, right? Then now see D here, second row, third column, second row, third column. So D equal to 194. Okay, so we can say for the unknown, the one we have here, like this one, right? This one gonna equal to 212. Okay. So when you read this one, can say this is the meaning of equality of matrix. They must be in the same position, right? Like this one, for the position A, we read as a row, first column, first row, first column. So this first row, first column. So A equal to 212. And the rest read the same way. Okay. Then you can see the two matrices are equal if they have the same, see this, if they have the same order, this is the same order, correct? 2 by 4. And if their corresponding elements are equal, then we can get corresponding. This means each element in the same position will be equal. Okay. Then, so let's talk about the meaning of equality of matrix. But see the example I give you a little bit more. If I lay down here, okay, separate them here. If I give this one, say if I give the matrix, for example, matrix, maybe say 1, 6, 3, 9, like this matrix. And this one, negative 6, no comma, and 3, 9. So my question gonna ask you that this say I give this one maybe matrix A and this one matrix B. Does matrix A equal to matrix B? My question asks, matrix A equal to matrix B or not? Whether or not? You check, right? Now you check matrix A, matrix A. How many row and column we have? What the order? Just say. Find the orders. Order is what? One, the row one, row 2, row 3. So we have 3. How many column? 1 column. And then you see matrix B. How many row we have? 1, right? And this one, how many column? 3 columns. We have 3 columns. So times 3. When you see this one have order is a 3 by 1, and this one by 3. So this one is different order. Okay, this one have the different orders. In this case, this matrix A, matrix B does not equal. Even though inside you check, even though each element negative 6, 3, 9, negative 6, 3, 9, they are same, right? Same element, same number, same size, exact same number, but still count to be different order. So this one does not equal, okay? Does not equal. If equal have to be exactly same order, okay? Exactly same order, and then you can list in each position, in each element in the same location. You can say they're equal, like this example, okay? But in this case, they have different order. So we can say matrix A doesn't equal to matrix B. The reason is they have a different order. They have different order because it's 3 by 1 and this 1 by 3. So not the same. So in this case, when we're gonna say they are same, have to be exact same. Like for example, I give that this way. Say maybe negative 5, 2, and then maybe 3, 4 like this one. If I like this, you can say they're equal. This is really obvious. Okay. This one, they are equal, but not all corresponding elements are equal. Okay, this one equal now. Because they have same 2 by 2 and 2 by 2. This one can say symmetric, really clear, this one, correct? But again, this is a good example here. Because they are different order, so they are not equal. Okay, so I think that's all for now. For now, I will give you assignment to practice. There are about 6 to 7 questions. I will post in the GC. Okay, or you can check in the Line group also. Please turn on your Line group and read the message they give to you. Everyone must read and follow and try to finish your work as soon as possible. Okay, that's all for today. See you next class. Bye bye.